So in the last couple of videos, I gave you a sense of how this global workspace, working memory, contributes to both our intelligence and to other animals' intelligence, like crows. And I gave you this idea that how human minds differ from the minds of other animals, like crows and chimpanzees, is that we just have a greater working memory capacity. And in fact, individual humans seem to have different levels of working memory capacity. A lot of recent work seems to indicate that what we're measuring when we measure IQ, intelligence quotient, is just really measuring how much RAM individual humans have, how much capacity we have to juggle thoughts all at once in our working memory. And this makes kind of sense if you think about those Raven's matrices we were looking at earlier as one of the things that you use working memory for. If you've got more working memory, you can juggle more thoughts, so you'll probably be better at answering those Raven's matrix questions, and asking people how to solve those questions is one of the main ways that we measure IQ. So there you go. That's one way in which people's intelligence of a certain kind, at any rate, can vary. Now, I promised you I'd show how our use of human language and our social practices can also contribute to our unique sort of intelligence. So here's an example about how language might help us to think through problems in a way that an animal is unable to. So here's a little experiment I talked about a little bit in a comment on Perusal. What you can do is put a little rat here in a room, a rectangular room that we've got right here, and you can put a little box in each corner and then hide some cheese behind one of the boxes. And you let the rat see, look, I'm hiding some cheese over here behind this box. All right, and now key is that this room is rectangular, so two sides of the room are shorter than the other sides, and one wall of the room is blue. So now what you want to do is you let the rat see where you're hiding the cheese. You see that you're hiding the cheese over here. And then what you do is put a little blindfold on the rat, and then you just spin it all around, get it really disoriented, and then take the blindfold off. Okay, so now you've put a blindfold on, spun it around, take the blindfold off, and now you want to know, can the rat remember or figure out where the cheese is? And so once you do this to the rat's almost inevitably, they'll shake off the blindfold and they look around the room, and they almost inevitably go either to this corner over here, which is indeed where the cheese is, or half the time, they also go to this corner over here, which of course is where the cheese does not exist. Now, why do they do that? Well, you might think that in the rat's working memory, it was able to keep track of two different ideas. One idea is that the cheese is next to one of the short walls. So, it's either against this short wall over here or this short wall over here. And then the other idea it was able to keep in its working memory as it was being spun around is that the cheese is to the left of one of the short walls. And then it ran out of working memory space. And so when you let it loose, take the blindfold off, it knows that, the cheese is either to the left of this short wall over here, which will get it the right answer, or it's to the left of this short wall over here. And that's why the rat, at 50-50 chance, either goes over here or it goes over here, because it can only hold in its working memory that the cheese is to the left of the short wall. And in fact, it seems that rats and other rodents, they seem to have a little bit of their mind that's devoted to just processing the geometric configuration of their space. So they can think in terms of short things and long things and left of and right of, and so it's easy for the rat to hold in its working memory the idea of being left of a short wall. Now, you could do the very same experiment with an adult human like myself, and indeed psychologists have done that. So you put the human in a room and you show them, look, I'm hiding this piece of cheese over here. You might use something else with an adult human. It doesn't really matter because we're not, quite as motivated by food as rats are. But you show them, look, I'm hiding something over here. And then you put a blindfold on the person, spin them around, take the blindfold off and look to see, can they figure out where the cheese is? And humans, we're really good at this. The adults are, at any rate. We're able to go, yep, cheese is right over here. Now, why is that? Well, we seem to be able to make a use of the fact that one of the walls in the room is blue in color, in distinction from the other walls, which are, white or black in this case. So when we look at the cheese being hidden, we can remember in our working memory, aha, the cheese is to the left of the blue wall. So we can hold those two thoughts together, left of and blue wall, together in our working memory, and that's enough to pinpoint exactly where the cheese is. Now, some folks, like Peter Carruthers and the psychologist Elizabeth Spelke, think that the reason why we're able to hold this idea of being left of the blue wall instead of just being left of the short wall in our working memory is because we have language. We can actually use the words blue wall and the word left of and just kind of say that over and over to ourselves in our head as we're being spun around for the blindfold. You can say, okay, left of the blue wall, left of the blue wall, left of the blue wall. And that's what allows us to keep that going and rehearsed in our mind so that when the blindfold comes off, we know, right, left of the blue wall. Those are the words I remembered in my language. That's where the cheese is. And it is interesting, if you do this experiment with a human child that's less than 5 years old, they behave just like the rats. They either look here or they look over at this area. And it's also interesting that around 5 years old is about the time when children start becoming good at using the terms left of and right of. So Spelke and Carruthers think that language is this way of taking our thoughts about spatial geometry, things that are long or short or left of or right of something, and combining those kinds of thoughts with thoughts about other stuff, like colors, for example. So it's because we have words for the notion of being left of or right of something, and we have a word for the color blue, we can combine thoughts about blueness with thoughts of being left of something, rehearse that in our working memory, and get to the cheese every time. Because mice and rats and little human kids under the age of 5, they don't have words for left of or right of, or they're not terribly good at using them. They aren't able to combine thoughts about being left of and right of with thoughts about blueness. They just have to rely on kind of the subconscious part of their mind that's able to think about left, right, long, short, etc., but can't combine those ideas of left and right with ideas about blue and black and white and other colors. Okay, when I come back, I'll give you one more video about how we not only use a souped up RAM capacity and possibly our ability to speak language, but our social practices to soup up our intelligence as well.